Let's go through Liquid 1248. Count number of nice subarrays. So for this question, it asks how many subarrays which have the odd number counts to be k. So what we think about is that we can look at this kind of subarray, and it is an odd, right? So the number mod 2 equals 1. Then we have count plus plus add the counts. And when this count equals to k, right? So if we already have the, so we can have an index here, right? So we know from the subarray, which can the right index can extend from this kind of order to the next order, right? Next order. So next order, or possibly if there is no next order, can extend to the end, right? So we'll say if we have the right count here, right? In this case we can calculate the right count. That means for every we may also have a left index, right? So we'll say if left index they didn't move, there are this kind of right counts of subarray which have have the nice subarray, right? And for the left, what we think about is that as long as this left is pointing to even number, right? This kind of left we can move. That means until it meet to the first order, right? So we can count from here to here how many even numbers, right? And the count, let's set this one initially to be 1, right? So that the result will be the left count plus equal to the left count multiplied by the right count, right? And when we're trying to move, I think let's move. We should move the right index to just one previous to the other number, right? And when we move, we set the left pointer to the one index after the, if it meet odd number, let's set it to just one after the odd number index, so that we can count how many here and how many here, right? And sum them up. So let's begin to write code for this. So we have int result equals to 0, right? Let's have n equals nums dot length, and we have left pointer, right pointer, left equals to 0, right equals to 0. For right smaller than n, right plus plus. So we know if for this nums right mod 2 equals to 1, right? That is, this is the odd number, so we need to have the a count, right? Also need a count plus plus. So if this count equals to k, right, then we need to calculate those kind of counts on the right, right? So we know right count, at least we have one subarray, right? Satisfies our condition. And we want our right counts, right index to move just one before the next out, right? So we can use while right +1, smaller than n, and right nums right +1 mod 2 equals to 0, right? So in this case, we have right count plus and also right plus. Right? And for the left, right, we'll say while we also have the left count in left count equals to 1, right? Because at least there is one subarray, right? So as long as there is one more zero, one more even, right, in the left, while nums left mod by 2 equals 0, right? We're going to have left plus. And we'll have a left count plus as well, right? And in this after this left pointer is pointing to the next odd number, right? So we need to have the left pointer. So first thing we need to sum this up to the result, and then let's move our left pointer to the next one after this index, right? And if this one move to the next, we remove the one odd number from our counts. Right? So what do we need? We will do three things. First is that our result plus equal to right count multiplied by left count, right? And we're going to have our left increased by 1 to be the one after this odd number, right? And also we'll have a count minus. And in the end, we return result. +1. Okay, doing like this, the time complexity is O(n) and the space is O1.